These notes are for the end of Unit 4, Analyzing and Transforming Functions for Algebra 3. I'm going to cover two sections in this unit because they're very much related, and this is review of Algebra 1 and Algebra 2, and even some of geometry. So we're doing linear functions and slope, and then more on slope. Slope you've heard so many times, you probably wonder why you have to keep learning it, but it really is a strong foundation for what we use in a lot of math and science courses. Slope is the average rate of change of Slope is the average rate of change of y with respect to x. We only use y and x in math so you can learn the techniques. But when you go on to other classes, or even in here, we're going to do some word problems where we're not going to use y and x. Maybe we're going to talk about the average rate of change of your pay with respect to how many hours you've worked. So slope is represented typically by the variable m. This is universal. M is going to be the change in y, so y2 minus y1 over x2 minus x1. I'm going to start using this delta x and delta y. Delta just means change. It's a Greek letter, and you're going to see it more in science classes. So I always start using it in Algebra 1. So to represent a line with a positive slope, that means as x increases, as x is going up, y is going up. So y increases as x increases. A negative slope looks like this. So y decreases as x increases. So it really is about what's happening to y. Y is increasing, you have a positive slope. Y is decreasing, you have a negative slope. A zero slope means y doesn't change up or down. So y stays the same. It's constant. But x is still increasing. And an undefined slope goes up and down. So x never changes. This is not a function. If you have an undefined slope, it's not a function. But it's still an important part of what we study. So lines, a line is a continuous function, has many forms. Slope-intercept form is the one most of you have seen in Algebra 1. So slope-intercept form would be y equals mx plus b, where slope is represented by the letter m, and the y-intercept is represented by the letter b. So example here, I want you to write the equation of a line with the slope of 6, so I know this is my m, and a y-intercept of -3. So I know that this is my b. So I just have y equals 6x minus 3. A standard form is not used as often as has its purposes. You'll see a few of these problems here. But standard form is usually written ax plus by equals c. It's also called intercept form. So what's important about a, b, and c is they are all integers. There are no fractions. And a is going to be positive. I don't use standard form that often, but I want to make sure that you got to see it. The one I use most often is this point slope form. For me, it's the least amount of work. So point slope form is y minus y1 equals mx minus x1. Slope is still the letter m. That will never change. But this time, instead of using the y-intercept, I'm going to use this point x1, y1. So for example, I've got, I want to write an equation of a line going through these 2 points, -2, 5, and 4, 3. So it doesn't matter which point is x1, y1 and which point is x2, y2. Most of you are very comfortable calling this x1, y1 and this x2, y2. I could have written them in a different order and I would still get the same answer. It doesn't matter. So So the first thing I want to do is find slope. So I've got my slope is change in y, so 3 minus 5 over my change in x. 5, 3 minus 5, 4 minus a negative 2. My slope is going to be negative 2 over 6, and I'm going to reduce it to negative 1/3. The second thing I'm going to do is find my equation. So I know my slope, and I'm going to use this first point, x1, y1. So go back up here, I have y minus y1. So y minus 5 equals the slope, so equals negative 1/3. And then I want x minus x1. X minus x1 is negative 2, so x minus a negative 2. Most of the time I leave it like this, but I can rearrange this easy enough to show you how it goes into slope-intercept form. So I'm going to first distribute this negative 1/3, so I get negative 1/3 x minus 2/3. Then I'm going to add 5 to the other side, so I get y equals negative 1/3 x. Negative 2/3 plus 5 will be negative 2/3 plus 15/3. So I get 13/3. And then before I put a box around this, I'm going to check it with the calculator. So I'm going to go to my y equals. Actually, I had just typed this in to make sure, but I'm going to go back here and I'm going to type in, I want the fraction, but I want negative 1/3 x plus 13/3. And I'm going to go through my table of values. I want to see if this point here, negative 2,5, is in the table, and I want to see if this point 4,3 is in the table. So right there at the very top, negative 2,5. And then down here at the very bottom, I have the point 4,3. So now I know that that works. Also with slope, horizontal lines are special lines, and the slope of a horizontal line is always 0. If you have a horizontal line, the equation is going to be y equals some number. And I'll show you examples below. Vertical line, the slope is always undefined. And the equation is going to be x equals a number. And this is where teachers teach different things, and I'm not sure what you were used to. If somebody said there wasn't any slope, sometimes people refer that to as a horizontal line. Some people refer that to as a vertical line. So I pretty much stay with 0 and undefined. To graph the lines, this first one I have in slope-intercept form. So I'm going to start out with my intercept. My y-intercept is 3. So along the y-axis, I want to make sure I start at a positive 3. My slope is 2. So that means I want to go up 2 and over 1. But I want to go to the right. So if I go up 2, I'm going to go to the right 1. And to make it easy for myself, I just start plotting all these points. So if I go up 2, right 1, I can also go down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. And that makes it easy for me to draw the line. Same idea. I've got this one here is in point slope form. I could rearrange it if I want to, but if I rearrange it, I have the chance of rearranging it incorrectly. So I'm going to leave it like this and just graph it from here. So I have the point negative 1, positive 2, because my formula is y minus y1 equals m x minus x1. So my point is going to be negative 1, 2. Let's start there. And my slope is a negative 3. If it's a negative 3, I can go down 3 and right 1. Down 3 and right 1. Or I could go up 3 and left 1. Now that I've got all my points marked, I'm going to turn this so I can draw it better. Probably should grab a ruler, being a little bit lazy. There's a little bit of bend to it, but you understand. Then I've got a horizontal line. This one has a slope of 0 because it's y equals a number. Y equals -2. So I'm going to make a hash mark at -2, and I'm just going to draw a horizontal line. This next one, my slope is undefined. It's going to go straight up and down. It does not pass the vertical line test because it is a vertical line. So it's going to be x equals 3. I'm going to make hash marks to get to 3. And I'm going to draw a vertical line. And then one concept that students tend to struggle with frequently is this idea of parallel and perpendicular lines. They follow you throughout calculus and beyond, but parallel lines, they have the same slope. So my example here, y equals 2x plus 3. So I'm going to first graph that. My y-intercept is 3 and my slope is 2. So up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to draw that line. My next equation is y equals 2x minus 1. Well, you could see my slope is 2 and my slope is 2. They have the same exact slope. So this one has a y-intercept of -1, so I'm going to start at -1, and I'm going to go up 2 over 1, 2 over 1, down 2 over 1, down 2 over 1. No matter what happens, these lines are not going to intersect. They are parallel. So now I've got perpendicular lines. Perpendicular lines, the slopes of them are going to be opposite signs. So if one's positive, the other one's got to be negative. And they're going to be reciprocals. You're going to flip them. So these two here that I have are going to be opposite signs. So this is a positive 2, this is a negative. They're reciprocals. The reciprocal of 2, this is 2 over 1, is going to be 1 over 2. So once again, if I graph y equals 2x plus 3, and if I graph -1/2 x minus 3, so we start -3 on the y-axis, and we go up 1, left 2, up 1, left 2. Or I can go down 1, right 2, down 1, right 2. So you can see those are perpendicular. That makes a 90-degree angle.